Welcome students. Today we'll discuss the topics from chapter 3, motion in a straight line. So the first topic we'll discuss is speed. Define the term speed, whether it is a scalar or a vector quantity, give its unit and dimension. Now the speed is the rate of change of position of an object with time in any direction. It is equal to the distance traveled by the object per unit time. So what it says, it is the rate of change of position. Rate of change of position means how fast it is changing its position in any direction. I'm focusing on in any direction. That means direction is not important here. What is important? Only the rate of change of position. Fine. Next we will discuss whether it is a scalar or a vector quantity. Speed has only magnitude, no direction, so it is a scalar quantity. As I've already said that speed has only magnitude. Magnitude means your numerical value. And no direction, that means it does not depend upon any direction. Therefore, it is a scalar quantity. The SI unit for speed is meter per second. The CGS unit of speed is centimeter per second. And the dimensional formula of speed is m to the power 0, L to the power 1, T to the power minus 1. Now let us discuss about different types of speed. So define uniform speed and average speed. Uniform speed. An object is said to be moving with uniform speed if it covers equal distance in equal intervals of time, however small these time intervals may be. So uniform speed means whenever your object covers equal distances in equal intervals of time, then we call that speed as uniform speed. Next, your average speed. Average speed for an object moving with variable speed. The average speed is the total distance traveled by the object divided by the total time taken to cover the distance. Average speed means the total distance. Means suppose you are going from point A to B and then you return from B to A. In this case you are moving or you are covering this distance twice. So average speed will be the total of this distance and the total time it takes to cover this distance. So average speed equals total distance traveled by total time taken. Fine. Now moving to our next concept, velocity. Define the term velocity. Is it a scalar or a vector quantity? Give its unit and dimension. Velocity, the rate of change of position of an object with time in a given direction is called its velocity. It can be or it can also be defined as the speed of an object in any given direction. It is equal to the displacement covered per unit time. Velocity equals to displacement by time. Now what is a velocity? Velocity is the rate of change of position. How fast is the position of the object changing with respect to time in a given direction. Put your focus here, in given direction. That means we have to specify the direction also. It can be also defined as speed of an object in a given direction. We can use the speed of the object to define the velocity, but we also have to mention about its direction. It is equal to the displacement covered per unit time. What was your displacement? Displacement was your shortest distance between your initial and the final position divided by your time taken. Fine. Now, as you can see here, your velocity has the magnitude. Magnitude, that means the numerical value, and it has the direction. Since it has a magnitude and direction, therefore it is a vector quantity. Now, let us discuss about different types of velocities. Before we discuss different types of velocities, let us define the SI unit, CGS unit, and the dimensional formula for velocity. So the SI unit for velocity is meter per second. The CGS unit of the velocity is centimeter per second, and the dimensional formula is m to the power 0, L to the power 1, T to the power minus 1. So everything is same like speed, only difference is velocity has direction, whereas your speed doesn't has any direction. Let's move on to next topic and discuss different types of velocity. Different types of velocities. Fine. Define uniform velocity. Uniform velocity. A body is said to be moving with uniform velocity if it covers equal displacement in equal intervals of time. However, small this time intervals may be. That means whenever your body covers the equal displacement, means it covers equal distance but with respect to some direction in equal intervals of time, then it is called uniform velocity. Next, average velocity. Average velocity for an object moving with a variable velocity. Average velocity is defined as the ratio of its total displacement to the total time interval in which the displacement occurs. Average velocity means total displacement. You have to sum up all the displacement and divide it by total time taken. Fine. So it will be more clear if you will solve this example. A car is moving along x-axis. This is your x-axis. As shown in the figure, it moves from O to P in 18 seconds. The car moves from, this point is your O. It moves from here till here. In how many seconds? 18 seconds. And how much distance it covers? 360 meter. And returns from P to Q in 6 seconds. So if it takes 18 seconds, again 1 second, 2 second, 3 second. A car is moving along the x-axis as shown in the figure. A car is moving along the x-axis. This is your x-axis. Fine. It moves from O to P in 18 seconds and return from P to Q in 6 seconds. That means this car moves from the position O to P in 18 seconds and it covers 360 meters. And then again it moves from P to Q. Now in this case it covers 360 and 240, that means 120 meters, and it covers its distance in how many seconds? 6 seconds. How come 6 seconds? See, 18, 6, 2 seconds, 16 to 14, 2 seconds, 14 to 12, 2 seconds. Okay, this doesn't mean that time is going in reversal. Okay, it just means your 2, 4, 6. Fine. It is not going 18 to 12. Okay, don't get confused. Now, what are the average velocities and average speed of the car in going from O to P? So you have to calculate your average speed. Average speed will be the total distance travel. The total distance travel from O to P is how much? 360 meters. And the total time taken divided by your total time taken, it takes 18 seconds. So 18 to the 20 meter per second. So your average speed is how much? 20 meter per second. Similarly, your average velocity. This is your initial position 0. This is your final position 320 meter. What is the display? Sorry, 360 meter. What is the displacement distance between your initial and final, which is how much? 360. How much time it takes? 18 seconds. So 360 divided by 18. Again, you will get 2 meter per second. Fine. Now, for the part 2, from O to P and back to Q. Now, in this case, what happens? The car first moves to P and then from P back to Q. Now, you have to be very, very careful. Okay. Let us first start by calculating your average speed. Average speed will be the total distance traveled. Now, in this case, how much is the total distance traveled from O to P? 360 meters. And then again, P to Q, how much distance travel? 120. So 360 plus 120 is how much? It is 480 meters. Fine. Now, how much time it takes? From O to P, it takes 18 seconds. And from P to Q, it takes 6 seconds. So 18 plus 6 is how much? 24. Therefore, if you calculate your average speed, it will be somewhere around your 480 divided by your 24. 24 2s are 480. So it will be somewhere around 20 meter per second. Fine. Now for your average velocity. Now for average velocity, what you have to consider? The total displacement. In this case, what is your initial position? 0. What is your final position? 240. This is your final position at point Q, right? So what will be the displacement? 0 to 240, not again 480. Fine. This is where most of the students make a mistake. So the total displacement will be 240. Fine. But what will be the total time taken? The total time taken will be the same like previous. It has to go to P and then back to P to Q. So the distance travel will be 240, but the time taken will be 24. So 240 divided by 24 will be how much? 10 meter per second. So here you understand what is the difference between the average speed and average velocity. In average speed, it didn't matter in whichever direction it went, but average velocity is always measured in this positive direction. Is it clear? So you solve this example as a homework to get a better picture. Now, let's move on to the next topic. Uniform and non-uniform motions. What is meant by uniform motion? An object is said to be in a uniform motion if it covers equal distance in equal intervals of time. However small these time intervals may be in the same fixed direction. What does this mean? Whenever your body covers equal distance in equal interval of time. Fine. This is your uniform motion. For example, you can consider, suppose an object covers 1200 meter in 1 minute in a given direction. Fine. Suppose the object covers how much distance? It covers 1200 meters. Okay. Now, what actually happens is that it covers some equal intervals of distance in equal interval of time. So, if it is covering this one, let us say from your 0 to 600 meters, somewhere here. Okay, 600, this is your 600 meter. This distance is traveled by the object, let us say in 30 seconds. So what happens if this is 600, then this distance will be also 600, and the car takes 30 seconds also to cover this distance. Fine. So what do you notice? It is covering equal distances, 600, 600 in equal intervals of time, 30 seconds and 30 seconds in a given direction. Fine. Now let us move on to the non-uniform motion. A body is said to be in a non-uniform motion if its velocity changes with time. Fine. What does this mean? If the velocity changes. What do you mean by velocity change? It means whether the numerical value of this velocity changes. That means it covers unequal distances, or when the direction changes. If the direction changes, so as your velocity will also change. In that case, it will be a non-uniform motion. Fine. So that's it for today's class. Thank you. If you have any confusion, please do ask. I will re-explain it to you again.